Welcome to Future of India. Today our topic is electrostatics. If we break this word in two parts, then electro and statics. Electro means related to electron, that is charge, and static means at rest. So in this chapter we are going to study about the charges at rest. So what is electrostatics? It is the branch of physics which deals with the study of charges at rest. Forces, fields, potentials, etc. So in this chapter we will study about the charges at rest, their property, forces between different charges, their electric field, potential, etc. The most important term here is electric charge. You may have asked the question that what is electric charge? This is a very common term. So it is basically the property of material by which it can apply or experience electric and magnetic effects. So it is the property of matter by virtue of which it can apply or experience electric and magnetic effects. In the 10th standard, you have studied about the types of charges. That charges are of two types: positive charge and second one is negative charge. And you also studied that same charges repel each other and different charges attract each other. Like charges repel each other and unlike charges attract each other. If I put positive charge, then they will repel each other. If I put negative charge, then also they will repel each other. But if I put positive charge and negative charge, then they will attract each other. So same charges, either positive or negative, they will repel each other, and different charges, positive and negative, they attract each other. fundamental property of charge. We will study 4 fundamental property of electric charge one by one. The first one is additivity of charge. As the name suggests, additivity of charge. That means if we want to calculate total charge of any system, then we have to add them. So total charge of any system is algebraic sum of all the individual charges for this system. We have Q1, Q2, Q3, Q4, that is Qn. And charges are present in this system. Then total charge will be Q is equal to sum of all the charges. That is Qn. Here is one term, that is algebraic. Algebraic means with their proper sign, positive or negative. If charges are positive, then put plus sign. If they are negative, then put negative sign before them. Our second property is invariance of electric charge. Invariance means that is not varying. So charge of any body does not depend upon frame of reference. Look at the body. This is our Cartesian plane. If I put a charge plus Q here, and if I change the frame of reference from here to any other place, then the value of charge remains same. So charge of any body does not depend on frame of reference. So if I shift the Cartesian plane from here to any other place, then value of Q remains same. We can also say that charges does not depend on relative motion between the charges. If I put Q charge at this cluster and if I move it with a constant velocity or constant acceleration, then the value of charge will not change. So we can write Q kinetic charge at rest is equal to Q at motion. Our third property is quantization of charge. It is very important property. Quantization of charge means if we want to transfer charge from one body to another body, then we can transfer charge only in the form of integer multiple of electron. If I want to transfer charge Q, then it will be integer multiple of E. E, that is charge on electron. We can transfer charge from one body to another only integral multiple of charge, integral multiple of electron. If I want to transfer charge from this duster to this chalk, then minimum charge that we can transfer is of 1 electron. If I want to transfer more charges, then it will be in the multiple of electron, like 1 electron, 2 electron, 3 electron, and so on. We cannot transfer charge as a fraction. Like if you want to transfer E by 2 charge, then we cannot transfer. Similarly, E by 3, we cannot transfer E by 3 charge. So Q is equal to N into E. N is 0, plus minus 1, plus minus 2, and so on. So this is the formula. Q is charge, N is number of electron, E is charge on electron. Here we know the value. E is equal to 1.6 into 10 raised to power minus 19 coulomb. So this is the value of E, 1.602 into 10 to power minus 19 coulomb. So if you want to transfer the charge, then it will be always an integral multiple of E. Our fourth property, that is conservation of charge. The word conservation suggests that it will be conserved. So total charge of any isolated system remains constant or conserved. Total charge of isolated system remains conserved. We can say another form also that charge cannot be created nor destroyed. It can only be transferred. From one body to another. Total charge will remain the same. So these are our four basic fundamental properties. First one is additivity. Total charge of any system is equal to algebraic sum of all the charges. Second one is invariance of electric charge. That means charge of a system does not depend upon frame of reference. If I move the charge with constant velocity, then the value of charge remains same. Third one is quantization of charge. It means if you want to transfer the charge, then it will be always an integral multiple of E. And the last fourth one property is conservation of charge. That means total charge of any isolated system remains conserved. What do you mean by isolated?